This question is a XAT 2015 question. It's a part of the solutions provided by Ascent Education for XAT 2015 Quantitative Reasoning and Data Interpretation section. The section had a total of 31 questions. This is the first of the 31 questions. The topic that it appeared from is arithmetic progression. It's a really easy question. Let's have a look at the question. What is the sum of the following series? Minus 64, minus 66, minus 68, and goes down all the way up to minus 100. We've been provided with 5 answer choices. We need to find the sum of this series. What we're going to do is we're going to look at two ways of finding out this sum. The first one is a traditional textbook approach. And then we'll also look at a second approach and see if that saves us some amount of time. The textbook approach. The series, let's first have a quick glance at what this series is. The first term is minus 64, the next term is minus 66, the third term is minus 68. So I have basically added a minus 2 to the first term to get the second term. I've added a minus 2 to the second term to get the third term. So essentially each subsequent term is obtained by adding a common number, which is called the common difference, to the preceding term. So such a series is going to be an arithmetic progression. So these terms are in an arithmetic progression. There are certain key data for any arithmetic progression. We'll quickly list them down for this particular series. The first term of this series is equal to minus 64, which is usually called as the A1. A1 is the first term. The difference between any two consecutive terms is called the common difference, which is represented by the letter D. In this case, the common difference is equal to minus 2. The last term, which is called the AN or the nth term, is equal to minus 100. So these are the key data that we have. I'll give you the formula to find out the sum of the first n terms of an arithmetic progression. This is the formula. The formula is n by 2 into 2a1 plus n minus 1 into d. Where n is the number of terms, a1 is the first term as you have seen, and d is the common difference. What all data do we have right away? We have the value for a1, which is equal to minus 64 given in the question. We just about a little while ago computed the common difference to be equal to minus 2. So we also know the common difference. What we do not know is we do not right now have the value for n, the number of terms in the sequence. So the first job that we're going to do is to basically find the number of terms in the sequence. Right? This is how we are going to find it out. The nth term of an AP is given by this formula. An is equal to a1, which is the first term, plus the common difference added n minus 1 times. So it's n minus 1 into d. What all data do we have? We have data for AN, we have data for A1, we have data for D. We have all these three numbers. The only thing that we need to find out is N. So substitute it here, minus 100 is equal to minus 64 plus N minus 1 into minus 2, which is a common difference. So if you solve for this, we'll get N is equal to 19. So there are 19 terms in this sequence. So the only missing data that we had in this formula was basically the value of N. Now that we got the value of N, let's compute the sum. Sum of these terms is equal to 19 by 2 into 2a1. a1 is minus 64. So it's 2 into minus 64 plus n minus 1. We computed n to be equal to 19. So n minus 1 is equal to 18 into minus 2. Solve for this, you get an answer which is equal to minus 1558. Choice B is the correct answer. As I mentioned at the start of the video, we'll also look at a second approach to solving this question. The second approach is this. For any given set of numbers, these numbers need not even be in an arithmetic progression. For any given set of numbers, the sum of those numbers is going to be equal to the average into number of terms. See, how would we have computed the average? Average is always equal to sum divided by number of terms. So sum is therefore going to be equal to average into number of terms. Right? The only thing is, when it comes to an arithmetic progression, finding the average is quite easy. Let's check out how it happens. The average for an arithmetic progression is the first term plus last term by 2. In our case, the first term is minus 64. The last term is minus 100. So minus 64 minus 100 by 2 is equal to minus 82. So we have found out the average. In the previous method, we computed the number of terms to be equal to 19. So sum of the sequence is equal to the average minus 82 into the number of terms 19, which is equal to minus 1558. There are a couple of things I would like to point out at this point. For an arithmetic progression, for an AP, it works only for an AP, the average is equal to the middle term. The average of the sequence is always the middle term, right? How do I compute the average? The value of the middle term or the average is the first term plus last term divided by 2. Remember, these two things will come in handy in terms of solving these questions quickly. Choice B is the correct answer. Ascent Education provides a lot of assistance for XAT preparation, be it free questions that you can get in your mailbox when you sign up for our Yahoo groups, or you can watch these video solutions on our YouTube channel by subscribing to our YouTube channel, or you can attend classroom programs at Chennai. For all of these information, visit our website xat.ascenteducation.com.